Okay, let's look at Part G, number 42. So remember, we always want to write our given, and we want to write our find. All right. So it says a speeder passes a parked police car at 30 miles an hour. So, first of all, I'm going to say S is going to be speeder, and I'm going to call P is going to be police. So it says the speeder is going 30 miles an hour. So you notice I put V sub S. S stands for speeder. And the police car is initially at rest. I'm going to say VIP, the initial velocity of the police car is 0 because it says he's at rest. All right. So the police car starts from rest with a uniform acceleration. So now the acceleration of the police car is equal to 2.44 meters per second squared. A, how much time passes before the speeder is overtaken by the police car? So I want to find the time when one overtakes the other. What that means is they're side by side. So when they're side by side, what does that mean physically? That means that the distance of the speeder is equal to the distance of the police car. So what I'm going to do is, so when the police car catches up to the speeder, again, they're side by side. So that's going to help me to figure out what I need to do first. Now, what I would do in this situation is I might go like this, so I don't get confused, and I might say like speeder, and I might say police, because this might help me. So I know the speeder is moving at a constant speed. So he's moving at a constant speed. And at a constant speed, I know that the velocity is equal to x over t. So this would be the x over the t. So I know that x is equal to vt if I want to find x. Now for the police car, because he is accelerating, I know that x is equal to vit plus 1/2 at squared. The initial velocity is 0, so x is equal to 1/2 at squared. Now remember, when they're side by side, the x's are equal. So this x is going to be equal to this x. So what I'm going to do is I'm going to set these two equations equal to each other. So I'm going to say vt, that's the average velocity of the speeder times time, is equal to 1/2 at squared. What I would do next is I would try to simplify this. You notice how there's a t here and a t here? So if I factored out a t, it might make it a little easier. So I have v is equal to 1/2 at. And that makes it a little bit easier. Now I want to solve for t, because this is given and this is given. So I'm going to rearrange the equation and say t is equal to 2v over a. So it's equal to 2 times 30 meters per second divided by 2.44 meters per second squared. So now I'll have to do that on my calculator. So 2 times 30 is 60. So 60 divided by 2.44 comes out to be 24.59. So we'll say 24.56 seconds. So now I found time. Now how do I find x? Well, just like the last problem, I can use either one of these equations. I can use either this one, or I can use this one and substitute in for the time. So, well, that one's easier, so I'm obviously going to use the easier one. So I'm going to say x is equal to vt, so it's equal to 30 meters per second times the time I just found. And then I do that on my calculator. 24.6 times 30, 738. Now if I wanted to check my work, I could also use this one and say x is equal to 1/2 at squared and substitute in 1/2 2.44 times t squared, and I should end up getting the exact same answer if I want to check it. Okay, so either way is going to be correct. Whoops. So sometimes it helps to, you don't want to mix stuff up, and to conceptualize what does it mean when they're side by side. So side by side means their x's are the same. And that's how we're going to do these.